Bismillahirrahmanirrahim. Assalamu alaikum. So this is the practice problem number 7.1. So here we are going to solve this practice problem. In this circuit we have to find the Vx, the voltage of this resistor, Vc, the instantaneous voltage of capacitor, I0, this is the current flowing through this resistor, and V0 is the initial voltage of this capacitor at t is equals to 0. So for this, first of all we have to find the equivalent resistance of these resistors R, because the equation we have derived in the previous video is for the circuit looks like this, but this circuit is very complicated, so we have to shift these resistors into one resistor, and there is only one capacitor, so we have to find the equivalent of these resistors. So you can see that these two resistors are in parallel, so their equivalent would be 1/6 plus 1/12 is equals to 12. 2 plus 1 is equals to 3/12 equals to 1/4, and this is 1/R, so R would be 4 ohm. Now their equivalent is 4 ohm. Now 4 ohm resistor and 8 ohm resistor are in series, so their equivalent would be R is equals to 4 plus 8 is equals to 12 ohm. So that this resistor is 12 ohm, and we know that this capacitor is 1/3 farad. This capacitance is 1/3 farad. So the voltage of this capacitor would be V of C is equals to V naught E minus T over tau. This is the equation for the instantaneous voltage of a capacitor that we have derived in the previous video. So you should have to first you have to watch those videos if you did not watch. Now we have to find this. So this is the tau. Tau is equals to RC. So the R is 12 ohm and the capacitance is 1/3. So the tau would be 4. This would be 4 seconds. So let's put this in this equation. So V of C is equals to V naught is given 60 volt. Put this here 60 E minus T over 4. This is the tau. 60 E minus 0.25 T Vc voltage. So this is the voltage of a capacitor Vc. Now we have to find the voltage of this resistor. So you can see that their equivalent is 4 ohm, and there is 8 ohm resistor, and then there is a capacitor Vc. So the voltage of this capacitor is Vc, that we have now this is. So this is parallel to these both resistors. So you can also see that the voltage of this capacitor is also the voltage of 8 ohm and 4 ohm resistors, but we want to find the voltage of 4 ohm resistor, because the 4 ohm resistor is the equivalent of these two resistors. So the voltage of 4 ohm resistor is also the voltage of 6 ohm resistor and 12 ohm resistor, because these both are in parallel. So the voltage of 4 and 8 is the voltage of capacitor. So we will use the voltage divider rule on these both resistors. Their total voltage is this, so we want to find the voltage of this. This is Vx is equals to voltage divider rule. The total voltage is 60 E minus 0.25 T, and the voltage which we want to find the resistor is, here is the resistance of resistor. This is 4/4 plus 8. 60 E minus 0.25 T into 4/12. 4 1s are 4, 4 3s are 12. So 3 1s are 3, 3 2s are 6. So this is the answer, 20 e raised to power minus 0.25 t voltage. So this is the voltage of the resistor, this resistor Vx. So this is the Vx voltage that we want to find. Now we have find the voltage of capacitor Vc and Vx the voltage of this resistor. Now we want to find the current of this resistor. We already know the voltage of 6 ohm 6 ohm and 4 ohm resistor. 4 ohm resistor voltage is also this Vx, because this is the equivalent of these resistors. So the current flowing through this resistor is also the current flowing through 8 ohm. The current flowing through these resistors would be same. So we know the voltage of this resistor, so we apply Ohm's law on this resistor to find the current. The current passing through this resistor would be the same, this I naught. So I naught would be is equal to, so the current flowing through this direction, this is the potential of this terminal is 0 minus this node voltage is Vx. 0 minus Vx over resistance is 4 minus Vx over 4, and Vx, what is the value of Vx? The Vx is this 20 e raised to power minus 0.25 t over 4. So 5 is, so this is a minus e raised to power minus 0.25 t ampere. So this is the current that we want to find. Thank you for watching my video. So we have calculated those 3 parameters. So this is the finish. So thank you for watching my videos. Thank you so much.